At a time when the capabilities of artificial intelligences seem to be growing by leaps and bounds at an incredible pace, it's comforting to remember that there are certain cognitive processes that continue to feel distinctly human. I want to talk about one of those processes today. It's the idea of Eureka, a sudden flash of insight where the solution to a puzzle or a problem or a mystery just sort of clicks. When we think about these moments, several features come to mind. First, there is that suddenness. It's not that you slowly improve at solving a problem. You slowly improve, and then all of a sudden, you dramatically improve. Then there's the timing of the insight. It's variable. Given the same puzzle, some people get it quickly, some take longer, and of course, some people never get it at all. This process seems so singular, so qualitative, that it may appear like it would be impossible to study. But a study of sudden insight is exactly what we're going to be exploring today. Let's see if it clicks. Abandoning stories of Greek philosophers and kings' crowns, researchers led by Annika Low refer to these sudden flashes of insights as aha moments. Now, to me, an aha moment is sitting in my girlfriend's basement watching the Take On Me music video, but there's never a forever thing. Here, we're talking about those sudden flashes of insight, and in particular, whether a bit of sleep improves the chances of having them. The paper appears in PLOS Biology. So, how do you test aha moments in the laboratory? The system is actually really clever. Participants, 90 of them, were exposed to a very simple computer game that looks like this. Dots move around a circle in different directions, but one of 4 directions is more common than the others. So northwest, northeast, southwest, southeast. The participants are asked to press one of 2 buttons when they see the set of moving dots and are then given feedback if they are right or wrong. There's a hidden rule here. For example, to be correct, they need to hit the left button when the majority of dots are moving northwest or southeast, but the right button when the dots are moving northeast or southwest. They have to figure this out through trial and error. And it's not that easy, especially since there's a lot of noise in the direction of travel of the dots. But as you might expect, task performance improves over time. People figure out the rule underlying the correct answers and do better and better over iterated trials. Hundreds of them. As you're looking at the moving dots, though, you notice that the dots change color as well, from orange to purple at random. For the first 80% of trials or so, these color changes are random. They have nothing to do with what the correct answer is. But here's the trick. Towards the end of the series of trials, the colors start to match up with the correct directions. In other words, all of a sudden, orange dots would mean to press the left button, purple dots the right button. But the participants have to realize this is happening. No one tells them in advance. That requires a sudden flash of insight, an aha moment. But once a participant has that moment, their performance skyrockets. It's way easier to match a color to a button than 2 of 4 noisy directional trends to a button. And I find this super clever. Major props to whatever neuroscientist had the flash of insight to design this system. Okay, now we have a framework for measuring aha moments. The next step is to perturb the system. For this particular study, the researchers wanted to determine if sleep, and which stage of sleep, would improve this aha phenomenon. After an initial round of testing, where the color rule only appeared at the very end, the participants went into a quiet room to nap. An EEG was used to determine if they merely rested or reached stage 1 or stage 2 of sleep. Stage 1 sleep is pretty light, almost conscious. Stage 2 is slightly deeper, but still not really deep sleep. Only 1 participant reached stage 3 during the short nap. Some people figured out the secret rule before nap time. They were excluded from further study. So now we have a group of people who had not yet had their aha moment. Would the achieved sleep stage matter when they were tested again? It did. Pretty profoundly, too. About 50% of the group who did not sleep at all during the rest had the color insight during the second round of testing. About 60% of those who had stage 1 sleep had the aha moment, but 80% of people who reached stage N2 sleep had that insight, a statistically significant improvement. Interestingly, sleep only seemed to affect the proportion of people who had the insight. It didn't affect the time to the insight. And napping had no effect on task performance prior to the insight. Rather, it seemed that napping just allowed the magic to happen. But how does the magic happen? The researchers interrogated the EEGs to see if there was something deeper going on besides stage 2 sleep. They found that aperiodic activity in the brain captured all the information that sleep stage did. In fact, it correlated more strongly with insight than sleep stage itself. So, what is aperiodic activity and what is happening when aperiodic activity in your brain is higher? Aperiodic activity is electrical signals in the brain that don't have a nice repeating pattern. They seem more random and have been described by smarter people than me as the background noise of the brain. But what is interesting is what's happening to neural connections as aperiodic activity is increasing. They get weaker. This sounds bad, but weakening connections between neurons is actually a critical thing. It allows connections that are already weak and of poor quality to break entirely, allowing the stronger connections more exclusivity. Those of you in the machine learning space will recognize the similarity to regularization methods, but basically what is happening is that the noise of the complex brain is being turned down, so the signal can come through that much louder. And maybe that is the thing that allows the insight to happen. Maybe a brain with a bit less noise, a bit less clutter, has the ability to see more clearly, see the underlying structure being presented to it, and make those cognitive leaps that, for now, separate us humans from the neural networks we create in silico. Of course, looking at this study, I'm sure you're thinking the same thing I am. How can I leverage this knowledge to increase my likelihood of having Eureka moments? Well, getting better sleep seems like the obvious answer here, but I think we all knew that already. Maybe we can take a lesson from this idea of signal and noise. If the key to aha moments is allowing the stronger connections in our brain to function more cleanly without the distraction of those weaker connections, maybe that means we need to avoid those weaker connections if possible, those distractions. Does scrolling TikTok reduce your chance of having sudden insights? Does meditating in a quiet room increase them? I'm not sure, but at least now we have a mechanism to study those questions. In closing, let me express my wish that you have many aha moments and that they won't be gone in a day or two. For Medscape, I'm Perry Wilson.